In this class, now I am going to explain you a rectangular hyperbola. So we define this rectangular hyperbola from standard form of the hyperbola only. So standard form of hyperbola equation, x square by a square minus y square by b square is equal to 1 is the equation of a hyperbola. So if you see whose graph, so we get like this. See, x dash, y dash. This is Cartesian plane or xy plane. So in which if you draw the original hyperbola, usually we get like this. See, these are vertices. Let us say whose coordinates a comma 0 and minus a comma 0, and whose foci, one focus here you will get whose coordinates a comma 0, and one more focus here you will get, that is s dash minus a comma 0. Here this x-axis is the transverse axis for this hyperbola and y-axis will be the conjugate axis for this hyperbola. The distance from this vertex to this vertex is known as length of transverse axis, and we get conjugate axis on the y-axis, no? So whose length will be based on this hyperbola size. So here we take this length of conjugate axis will be 2b. You know that. So here from here to here distance is 2a. This represents what? Length of transverse axis. And conjugate axis length will be 2b. You know that. See, if length of this transverse axis is equivalent to length of conjugate axis, then such hyperbola is called a rectangular hyperbola. 2 cancel, a is equivalent to b. If a is equivalent to b, then this will be transformed into your x square by a square minus y square by a square, which is equivalent to 1. Now x square minus y square equal to a square. So this is known as a rectangular hyperbola. So for this hyperbola, x-axis and y-axis are called transverse axis and conjugate axis respectively. Even for this also, x-axis and y-axis are transverse axis and conjugate axis respectively. For this hyperbola, see, these are asymptotes. Here, this asymptote equation is x by a plus y by b is equivalent to 0, and this asymptote equation is x by a minus y by b is equal to 0. Meaning of asymptote. Asymptote is nothing but a tangent which touches this hyperbola at infinite distance. We can't able to recognize that point of contact. Somewhere this equation, this line will touch this hyperbola, but where it touches we cannot recognize. So such kind of lines will be called asymptotes. Asymptotes are nothing but tangents only. Okay, but where it touches this curve we cannot recognize, so that we people are naming these tangents as asymptotes. So for this hyperbola, x by a plus y by b equal to 0, x by a minus y by b equal to 0 are the equations of asymptotes. But in the case of this rectangular hyperbola, a is equivalent to b. So in these two asymptotes, if you put a equal to b, then this one will become x plus y is equivalent to 0. And here if you write a equal to b, and if you simplify, x minus y equal to 0. So here if you simplify both of them, y equal to plus or minus x. If you take plus, you will get 1. If you take minus, you will get one more equation. These two will be called equations of asymptotes of this rectangular hyperbola. Right? You know, for this hyperbola, eccentricity is square root of a square plus b square by a square. Now in which if you put b is equal to a, so then it will become e is equivalent to square root of here a square plus, replace this b by a square by a square. Now if you simplify, now 2a square by a square cancel. Now your e will be root 2 for this rectangular hyperbola. So for this hyperbola, e is root a square plus b square by a square. If you simplify this, you will get e value more than 1. You know that. But whereas for the rectangular hyperbola, eccentricity value is root 2. Okay. Now I would like to rotate this x-axis and y-axis in the clockwise direction for 45 degrees. Okay. So if you rotate this axis 45 degrees in the clockwise direction, this hyperbola will be transformed into other form. Now let us see that other form of rectangular hyperbola. See students, here x square minus y square equal to a square is the equation of a rectangular hyperbola. So now what I am going to do, now I am going to rotate the x axis, y axis 45 degrees in the clockwise direction. You know the relation between the old coordinates and new coordinates in the rotation of axis. So if you rotate theta angle, then you will get this relation. Now here small x equal to how much? So you have to close this. Small x equal to x cos theta minus y sin theta. Now in this rectangular hyperbola, to transform this one into the other form, so how much we are rotating that axis? 45 degrees. So that replace this theta by 45. Put theta is equal to 45 degrees. But we are rotating in the clockwise direction. In the case of clockwise direction, you would have to replace this theta by minus theta. You know that. This concept you learnt in the rotation of axis. So here, capital X into cos of minus 45 degrees. Here, capital Y into sin of minus 45 degrees. So if you simplify, cos of minus theta is equal to plus cos theta. X by root 2 you will get, sin of minus 45 equal to minus sin theta, minus of minus plus y by root 2. Now capital X plus y by root 2. Now replace this small x by capital X plus y by root 2. Similarly, small y is equal to capital X into sin of minus 45 plus y cos minus 45. Now if you simplify this, sin of minus 45 equal to minus sin 45 minus x by root 2 you will get, cos of minus 45 equal to plus cos 45. So y by root 2 you will get. Now here small y equal to how much? Capital Y minus x by root 2 small x equal to capital X plus y by root 2. Now replace this small x by that. So how you can write this? Capital Y plus x by root 2 whole square minus y value capital Y minus x by root 2 whole square, which is equivalent to a square. Now simplify this. If you simplify, what do we get? Tell me. So here in the denominator 2 you will get root 2 whole square. So this numerator looks like a plus b whole square minus a minus b whole square, which is equivalent to 4ab. 4 of capital Y into x, which is equivalent to a square. Now simplify. 2 ones are 2 2s are. Now xy is equal to a square by 2 you will get. So if you consider this a square by 2 is equivalent to c square, then it will become xy is equal to c square. So this is the other form of a rectangular hyperbola. It is obtained by x square minus y square equal to a square only. So how that has come? X square minus y square equal to a square? By writing a equal to b. As I said to you, length of transverse axis is equivalent to length of conjugate axis. Then hyperbola is called rectangular hyperbola. So from that x square minus y square equal to a square, you got xy equal to c square. By rotating that axis 45 degrees in the clockwise direction, we transform that x square minus y square is equivalent to a square. By rotating that axis 45 degrees in the clockwise direction, so this x square minus y square equal to a square rectangular hyperbola transformed into xy equal to c square. Now let us learn the properties of this xy equal to c square rectangular hyperbola. Right? Now see that. Now draw the new axis. These are new axes. Capital X dash, capital Y dash. Now see here. You people will get like this. Whose rough diagram. So this is graph of xy equal to c square. Now for this hyperbola, rectangular hyperbola, x-axis and y-axis are asymptotes. X-axis and y-axis are transverse and conjugate axis for the original hyperbola. And also x square minus y square equal to a square rectangular hyperbola. But whereas for this xy equal to c square, x-axis and y-axis are called what? Asymptotes. Remember this point. And you know, for this x square minus y square equal to rectangular hyperbola, y equal to plus or minus x are asymptotes. But whereas for this rectangular hyperbola, this y equal to x and y equal to minus x. Y equal to minus x are transverse axis and conjugate axis. Y equal to plus or minus x. Y equal to x and y equal to minus x equations are transverse axis and conjugate axis for this rectangular hyperbola, and x-axis and y-axis are asymptotes. Now, you know students, here for this rectangular hyperbola, x square minus y square equal to a square. So you got like this. Okay. Now where foci was a comma 0. For this rectangular hyperbola, e is root 2. So that here root 2 a comma 0 was the foci. focus, one focus and one more focus here you will get, that is minus root 2a comma 0. These are focus coordinates. Focus is a singular, focus is a plural. For this rectangular hyperbola, these are focus coordinates. But here we people are transformed this one into this form now by rotating this axis 45 degrees. Okay. Now this is one of the focus, root 2a comma 0 for this rectangular hyperbola. Now after transforming this x square minus y square into xy equals c square, this focus coordinates will change now. How it will change means, you know that relation, use this relation. Small x equal to capital X cos theta minus y sin theta. So now in which, so put theta we rotated 45 degrees, okay, in the clockwise direction, so that here what do you get, x cos minus 45 y sin minus 45. Now you got plus cos 45, now minus into minus plus y sin 45. Now small x equal to x cos 45. So here x plus y by root 2 you will get. Sorry students, here these are old coordinates. Here you want new coordinates. So you know that relation, new coordinates. So capital X equal to x cos theta plus y sin theta. Okay, now capital Y equal to, students tell me, so x sin theta, capital Y equal to minus x sin theta, plus y cos theta. Now in which replace theta by minus 45. Now x equal to small x into cos of minus 45 plus y sin minus 45. Now it is going to be x cos 45. Now this is minus y sin 45. Now x minus y by root 2. Here x value is root 2a and y value is 0. Now write here. So that here what do you get? Root 2a minus 0 by root 2. Now root 2 cancel. Now small capital X equal to how much? A. So if it is A, then your respective y value is also A. Because see here, whose equation is y equal to x, means x coordinate of every point on this line is equivalent to y coordinate. So that here we have written y equal to x now. Here you got x coordinate A. So that by default y coordinate also you can write A. So here we get one more focus, that is minus a comma minus a, because it is there in the third quadrant. I hope you have understood this, students. For x square minus y square equal to a square rectangular hyperbola, root 2a comma 0 is focus coordinates. After rotating this axis clockwise direction 45 degrees, this is transformed into small a comma small a. But in this we took c square is equivalent to a square by 2. Am I right? In the transformation you got xy equal to a square by 2, but that a square by 2 is taken as c square, no? Now if you would like to express this a in terms of c, so here a square is equal to 2c square, transfer this square to the right side, root 2c you will get. Am I right? Root 2c. So here root 2c comma root 2c is one focus coordinate, and other focus coordinates minus root 2c minus root 2c. Other focus coordinates. Similarly, students, now for this hyperbola x square minus y square equal to a square rectangular hyperbola, vertex coordinates are a comma 0 minus a comma 0. The same manner, see, after rotation, what will be the coordinates of this a comma 0? See, we want capital X no? Now capital X equal to how much have we got here? X minus y by root 2. Now here, x value a, y value 0. If you write here, now x equal to a minus 0 by root 2. Now a by root 2. If x is a by root 2, respect to y value also a by root 2. Now this is vertex for this rectangular hyperbola whose equation is xy equal to c square. Now here, what will be the coordinates of this vertex? A by root 2 comma a by root 2. A by root 2 comma a by root 2. Suppose if you would like to express in terms of c, you know that c square is equal to a square by 2. A square by 2. Now make a as subject. So if you make a as subject, you know. So, okay, root 2 c you will get. Now here we want a by root 2. A by root 2 means here root 2 c by root 2. Root 2 cancel c. So if you would like to express this vertex in terms of c, coordinates will be c comma c. Here also, whose coordinates are minus a by root 2 comma minus a by root 2. If you would like to express in terms of c, minus c comma minus c. Okay students, for this rectangular hyperbola, what will be the focus coordinates? A comma a or root 2c comma root 2c. So here minus a comma minus a or minus root 2c comma minus root 2c. Vertices coordinates a by root 2, a by root 2, otherwise c comma c. Here also minus a by root 2, minus a by root 2 or minus c minus c. Next, find the length of lattice rectum. So you know, for original hyperbola, length of lattice rectum we use it to represent with LL dash. So you know, 2b square by a. But for the rectangular hyperbola, a is equivalent to b. Now replace b by a. If you replace b by a, you will get 2a square means a into a by a. A cancel. 2a you will get. For x square minus y square equal to a square rectangular hyperbola. But whereas for this rectangular hyperbola, so this is the length of the lattice rectum for this rectangular hyperbola. But for this rectangular hyperbola, tell me students. So here, how much do we get? So 2a no? Now a is equivalent to how much? So for this rectangular hyperbola, so you know students, c is equivalent to, here you got to 2a. LL dash is 2a. Now if you would like to express in terms of c, you know c square equal to a square by 2. Now a is equivalent to root 2c. Now replace a by root 2c. 2 into root 2c. So this will be the length of length of lattice rectum. 2 into root 2c is the length of lattice rectum. Okay, next students, you know the meaning of auxiliary circle and director circle. So we have been learning from circles. Okay, now here I don't want to give you the definition of those circles, but I would like to give standard equations for this rectangular hyperbola. For this rectangular hyperbola, auxiliary equation, auxiliary circle equation. See, here we will get auxiliary circle equation. So you know how to draw that. So whose equation will be x square plus y square equal to 2c square is the equation of auxiliary circle for this rectangular hyperbola, and equation of director circle is x square plus y square equal to 0. This is the equation of director circle for this rectangular hyperbola, x square plus y square equal to 0. And next students, let us learn equation of a tangent and equation of a normal for this rectangular hyperbola. Now on this rectangular hyperbola, let us take any one point over here. Let us say whose coordinates x1 comma y1. Now tell me the equation of a tangent drawn to this rectangular hyperbola at this point x1 comma y1. How do you do, students? See here. You know how to determine the equation of a tangent. So on this tangent, so one of the point is known to you, x1, y1. This is the point of contact, no? That is common for this rectangular hyperbola and tangent. Still, if you know the slope of this tangent, then you can able to find whose equation. Now let us find slope of this rectangular hyperbola. So how do you find to get the slope of this tangent? We would have to differentiate this function with respect to x. Now x into dy by dx plus y into differentiation of x is 1, constant to differentiation 0. Now replace this by m, which is equivalent to minus y1 by x1 is the slope of this tangent. Now here you have slope and point. Apply the point slope form. So if you apply the point slope form, so what do you get? Y minus y1. So m value minus y1 by x1 of x minus x1. Now simplify, bring it to the left side. Yx1 minus y1 x1. When you multiply this, minus y1x minus into minus plus x1 y1. Okay, students? Right. Now send it to the left side. When you bring this one left side, yx1 plus xy1 plus yx1. When you transfer this one to the right side, 2x1 y1. But where is this point? Lying on this rectangular hyperbola, no? Replace xy by x1 y1. If you write x1 y1, then x1 y1 is equivalent to 2 c square. Now replace this x1 y1 by this c square. Students, if you write there xy1 plus yx1, which is equivalent to 2c square. So this is equation of tangent in Cartesian form. Equation of tangent of this rectangular hyperbola in Cartesian form is xy1 plus yx1 is equivalent to 2c square. So suppose if you want a normal equation, what do you do? What do you do, students? Normal. See, this is the rectangular hyperbola. Here it is point of contact x1 comma y1. Now this is tangent. Now this will be the normal. Normal makes 90 degrees to the tangent at its point of contact. So let us consider this tangent slope be m1. Now m1 is minus y1 by x1. Let us take this normal slope be m2. As you know, product of slopes of this tangent and normal is equivalent to minus 1. Now find m2. Now m2 is equivalent to minus 1 by m1. If you write this one over there, you will get x1 by y1 is the slope of the normal. Now find a normal equation. You know the point of contact, you know the slope of the normal. Apply the point slope form. Y minus y1, which is equivalent to x1 by y1 minus x minus x1. When you bring y1 to the left side, y1 minus y1 square, which is equivalent to xx1 minus x1 square. Okay, students. Now bring it to the left side. So here y1 minus xx1. When you transfer this one to the right side, y1 square minus x1 square. When you take minus common on both sides and cancel that minus from both sides, you will get xx1 minus y1, which is equivalent to x1 square minus y1 square. So this is the required equation of this normal xx1 minus y1, which is equivalent to x1 square minus y1 square. Next, see, if a point on the rectangular hyperbola, if you want to express in terms of a parametric form, So you will get like this. xy equal to c square is the standard form of a rectangular hyperbola. So suppose if you take one point as x coordinate as ct, then your respect y value will be now ct into y, which is equal to c square. 1c cancel. Your respect to y value will be c by t. C by t, where t belongs to any real number except to 0. So this is the parametric form of a point on this xy equal to c square rectangular hyperbola. Ct comma c by t, where t should not be 0. You can take any real number for t except to 0. Now, if you would like to express this equation of tangent in parametric form, what do? Same. So here xy equal to c square. Differentiate on both sides with respect to x. X into dy by dx plus y into differentiation of x is 1, 0. Now this is the slope of the tangent. Let it be m1 minus y1 by x1. Now substitute this value. So here minus c by t whole by ct. So cc cancel, minus 1 by t square is the slope of the tangent. Slope of the tangent you got. Now if you want to use equation, you know the point of contact, you know the slope. Apply points of slope form. Y minus y1, which is equal to m value minus y by t square x minus x1 ct. Now take this t square left side, yt square. So here minus c by t, so which is equivalent to minus x plus ct. Now bring this minus x to the left side, so that what do you get? Plus x. So x plus yt square, x plus yt square, which is equivalent to c by t plus ct. Okay, now students. Still, if you want to take a cross multiplication, you can. Otherwise, if you want to leave like this, you can. Still, if you go for simplification, xt plus yt cube, which is equivalent to c plus ct square, you will get. So this is the equation of tangent in parametric form. xt plus yt cube, which is equal to c plus ct square. The same manner, find equation of a normal in parametric form. What do you get? Now find the slope of the normal, m2. Slope of the normal will be t square. You know, if you take m1 into m2, again minus 1 you are getting, no? Hence, normal equation, slope will be t square. This is the normal, whose slope is m2, that is equivalent to t square. You know the slope and you know the point. So apply the point slope form. Y minus y1 c by t. Now m value t square, x minus x1 ct. Now simplify, yt minus c by t. So here t square x minus ct square, ct cube. Yes or no, students? Now send this t to the right side. Yt minus c. Now t power 4. Sorry, t cube. T cube x minus ct power 4. Okay. So bring it to the left side and send the t to the yt to the right side. So that what do you get here? ct power 4 minus c, which is equivalent to t cube x minus yt. So this is the required equation of normal for this rectangular hyperbola. I hope you have understood this class. So this is the rectangular hyperbola concept, how this rectangular hyperbola is generated, and I explained you whose properties. Thank you. Thank you one and all. I hope you people can utilize this concept for IIT Jee. preparation. Thank you one and all.